Chapter 6.5, solving radical equations. A radical equation is any equation that has a variable inside the radicand or has a variable with a rational exponent. A variable with a rational exponent is x to the 1/2 is equal to 4. A radicand that has a variable inside it is going to be the square root of x plus 4 is equal to, or x plus 2 is equal to 26. Those are your two examples. Do you understand that? Now, extraneous solutions are solutions that algebraically appear to be the correct answer. However, when we plug and chuck them back into the original equation, the left-hand side is not equal to the right-hand side, therefore producing a false statement. That is what we call an extraneous solution. Do you all understand that? Yay or nay? Yay. How do you find them?
Plug in.
Plug and chug. If you don't plug and chug, you can't find out if you're extreme. Steps in solving the radical equation. Step 1, isolate the radical expression. Step 2, take the square both sides. Now, this depends upon the index. If I'm squaring both sides, then my index would be what? 2. If I need to cube both sides, my index would be 3. If I needed to raise to the power of 5, then my index would be 5. Do we all understand that? Yay or nay? Number 3, solve the equation for the variable. Number 4, plug and chug, checking for extraneous solutions. Yes? Now, how do I eliminate the exponent on the following? X to the 2/3 is equal to 6. In other words, the question I'm asking you, are you listening, is how do I turn the power of 2/3 into a power of 1? Multiply by what? The reciprocals. What is the reciprocal of 2/3? 3/2. So what we're going to do is we're going to multiply both sides by the reciprocal, which is 3/2. And what we do to one side, we must do to the other. So 2/3 times 3/2 is going to give you 1. So I have x to the first is equal to 6 to the 3/2 power. Yes, we could calculate that out, but I'm not concerned about that at this point. Now, if we look at the next example, if I want to isolate this radicand, there's my radicand. What do I have to get rid of first? How do I get rid of the 2? Divide both sides by 2, and that's going to give you the square root of x cubed is equal to 3. Now, how do I get rid of the square root? I'm going to do the opposite of that, which means I'm going to square both sides. And power cancel out to give me x cubed is equal to 9. How do I get rid of the power of 3? Take the cube root of both sides to give me x is equal to the cube root of 9. Now, what do I want to draw your attention to? Everything we did in that example were opposites, correct? The opposite of multiplication is division. The opposite of a power is a root. The opposite of addition is subtraction. The opposite of a root is a power. So today is all about opposites. Do we all understand this, yes or no? Yes. Okay, absolute values. Now, we have to talk about absolute values because here's the thing, guys. Can you ever take the square root of a negative number? You can if you're in the imaginary number system, but we're not in the imaginary number system. We're in the real number system. So can we take the square root of a negative number? No, we cannot. So since we cannot, we have to make sure that if I have a problem like the square root of x, if x is positive, I'm okay. But if x is negative, I'm not okay, am I? So how do I ensure that x is always positive? By doing the absolute value, which means we have to then think about how we used to do absolute value. Remember, we had a case 1 and a case 2? Case 1 was the positive case, 3x minus 4 equals 10. Case 2 was the negative case. Negative, the jump underneath the absolute value bar is equal to 10. Do you remember this? Yes or no? Any visual and verbal from everybody that we understand when we did absolute value? Yes. Yay. We're not going to solve this right now. That's not the problem. Next example. What is the solution of 3 plus the square root of 2x minus 3 is equal to 8? Step 1, isolate the radicand. So if I'm isolating the radicand, that means I need to get rid of this plus 3 that's attached to it. So how do I get rid of that? Subtract 3, and I get the square root of 2x minus 3 is equal to 5. Now how do I get rid of the square root?
Square.
Square both sides. So when I do that, power and root cancel out. I'm left with 2x minus 3 is equal to 25. Why is that 25?
Put the square root of 5 first.
Because 5 squared is 25. We all good on that? Now how do I solve this? Add 3 to both sides. 2x is equal to 28. Now what? Divide by 2. X is equal to 14. So, how do I check to make sure that thing works? I need to plug and chug and make sure that that thing works. So how do I go about doing that? I have 3 plus the square root of 2 times 14 minus 3. Please do that. When I do that, what is 2 times 14? 28 minus 3 is? 25. Square root of 25 is? And what is 3 plus 5? Is 8 equal 8? Yes, that's a true statement. So is this x equals 14 an extraneous solution?
No.
No, it is the solution. Do we understand that? Correct. Next example. What do I do first? That's what a squared is. You don't have to do it. What do I do there?
Are you getting cookies?
I'm on it.
Yeah, you are.
I will.
Make sure you put your gas cap back on. That's when you guys do it.
While she's getting cookies.
X plus 1 over the 2/3 is equal to 4. Multiply by the reciprocal. The reciprocal of 2/3 is 3 over 2. Those cancel out. I'm left with x plus 1 is equal to. Now let's think about that a minute. What is this value right here? The 3 is the power. The 2 is the root. So what I'm telling you is we're taking the square root of both sides, aren't we? Can I take the square root of a negative number? No. So how do I ensure that that square root is going to be positive? I need to put absolute value bars around that x plus 1. Because if I don't, can I guarantee that that's going to be positive then? Do we all understand that? Why did I take and put absolute value bars there? Because my root is a 2. Whenever I did this, whenever I multiplied by the reciprocal of 3 over 2, my root was a 2. Do we all see that? The original power was even. So since my original power was even, that made my root become even, which then made this outcome have to be what? Positive. And the only way I can indicate that that's going to be positive is by making sure it is absolute value. Did we get that? Okay. Now this says I'm going to take the square root of 4 and then I'm going to cube it. So which one do I want to do? Are we listening? Do I want to make the number larger by cubing the 4 and then taking the square root? Or do I want to make the number smaller first by taking the root and then cubing it? Which is easier to do? Larger or smaller? Smaller. See, what we want to do here is take the square root of 4 and then cube it. What is the square root of 4?
2.
2. What is 2 cubed?
8.
To give you the absolute value of x plus 1 is equal to 8. Yes? So now, Now, I have an answer to the value problems. What do I do? Case 1 is x plus 1 is equal to 8. Case 2 is negative x plus 1 is equal to 8. So how do I solve this x plus 1 is equal to 8? Subtract 1, so x is equal to 7. How do I get rid of that negative? I could. That sounds like a lot of work. I could divide by negative 1, right? So I have x plus 1 is equal to negative 8. Subtract 1, x is equal to negative 9. Funny story though. What do I have to check? I gotta plug and chug not once, but twice. Anybody can plug and chug, right? So we're gonna check these to make sure that they work. So I have 3 times, what was my first answer? 7 plus 1 to the 2/3 power. What is 7 plus 1? 8. Do I want to take the square root and then or the cube root and then square it, or square it and then take the cube root? Bigger or larger? Bigger or smaller? I want to take the cube root first and then square it. So what is the cube root of 8?
2.
So 3 times 2 squared is? 3 times 4 is 12. Does 12 equal 12? Yep. So that answer works, doesn't it? What was my second answer? 3 times negative 9 plus 1. What's negative 9 plus 1? Negative 8. Cube root it or square it? Cube root it first. And what is the cube root of 8? Negative 8. Negative 2 squared is? 3 times 4 is? 12. It is a true statement, both of those work. Do we understand why you have to check your answers? Okay. Well, that was magnificent. Most importantly, what did we learn about this problem in our work? What did we learn? Why do we need absolute value buffers? Why do we need to make that right? What? We have an even power. An even power turns into an even root, which means I need to make sure that that is positive. Next. What should I do? Subtract 1. 3 times the 5th root of x plus 1 cubed is equal to 24. Now what? Divide by 3. The 5th root of x plus 1 cubed is equal to 8. Not 5 over 3.
X plus 1 is all the 3.
X plus 1 to the power is 3, the root is 5, is equal to 8.
Yeah.
What's he saying is he wanted it in rational exponent form. Now, what is my power? My power is 3. My root is 5. Are either one of those numbers even?
No.
So do I require absolute value bars? No, because we don't care. We can take the cube root or the 5th root of a negative number. Do we understand that? Okay, so now what do I do?
I'll follow the reciprocal.
The reciprocal is 5/3. No absolute value required. And do I take the 5th power or the cube root first?
Cube root.
So what is the cube root of 8? And what is 2 to the 5th power?
32.
And what do I do?
Subtract 1.
Subtract.
Back in.
Now what do you do to check it? Plug and chug. Anybody can plug and chug.
That's not true if you don't do it right.
What? Yep. We're going to skip the plug and chug on this one. Now, this one right here. Yes, it does work. How do you know? Good question. That's what I want to show you is, do you see this example? I have two variables on both sides, right?
Okay, back one stop. The last one.
Done right. Now, when you only have one letter, like we had in this example, and like we had in this example, and in this example, we have two letters. This one has one letter. You only have extraneous solutions generally, like 90% of the time, 95% of the time, when you have two letters. You with me? So all the ones on tonight's homework that have two letters, there's a strong possibility one of them is going to give you an extraneous solution. If there's only one letter in them, then do you think you're going to have any extraneous solutions? Probably not. So, step one, isolate your radical. So I need to isolate this. So how do I do that? Add the 5. So I have the square root of x plus 7 is equal to x plus 5. Now what? Square both sides. Why are we squaring both sides? To get rid of that root. So I have x plus 7 is equal to x plus 5 squared. What does that x plus 5 quantity squared mean? Then I have two of them there. So I write it down twice. So what do you think I need to do? FOIL. Good instinct. First is x squared, outer is 5x, inner is 5x, and last is 25. Now what's your gut telling you to do? Make it equal to 0 and combine like terms. Well, this is going to give you a 10x, and then if I subtract x and 7, I get 0 is equal to x squared plus 9x plus 18. Do you see how we combine like terms and then set it equal to 0 in one step? Now what's your gut saying to do? Put it back into two binomials. Since it's already equal to 0, I'm going to make this into two binomials, or I could use the quadratic formula, or I could complete the square, whichever method you would choose. X squared is going to be x and x. I need a positive and a positive, so it's plus and plus. Factors of 18 that give me 9 or 6 and 3. How do I solve this? I say x plus 6 is equal to 0, and I say x plus 3 is equal to 0. So my two answers are negative 6 and negative 3. Now how do I know if those two things work? Nope, don't assume, especially not on these ones. What do you think you have to do here? You got to check them. So I'm going to plug in negative 6. So what's negative 6 plus 7? 1. The square root of 1 is? 1 minus 5 is? Negative 4. Does negative 4 equal negative 6? No, that's a false statement. So since that's a false statement, that means that x equals negative 6 is not a solution. Do we understand that? That's your extraneous solution there. How did I know for sure I could have a strong possibility of extraneous solutions? I had two letters, two variables. Do we understand that? Okay, I need to plug in the negative 3. Negative 3 plus 7 minus 5 has to equal negative 3. What's negative 3 plus 7? Square root of 4 is? 2 minus 5 is? Does negative 3 equal negative 3? Always, therefore x equals negative 3 is my only answer. Do we get that? Now, I'm going to be really nice to you guys. I don't have any seniors in here. This is my only class, but I don't have a senior. So I'm going to be nice. I'm going to let you guys only have to do the evens type for homework. If you want to do the odds, you can do the odds for extra credit. 2 points, that's it. Now, everybody look at number 10. Number 10 on tonight's homework. How many fractions additional exponents do you see up there?
Two.
2. We're going to put them on opposite sides. So x minus 1 to the 1/2 is equal to 2x plus 1 to the 1/4. I added the 2x plus 1 to the 1/4 to both sides.
Use that.
Yep, I added the whole quantity. Now, what you're going to do is you're find the LCD between your denominators. My denominators are 2 and 4. Okay, so what's my LCD between 2 and 4? That's going to be a 4. Now, if you had your numerators, you'd have to do the same thing. Let's say we had 2/3 and 4/7. You have to find the LCD between the numerator and the LCD between the denominator. You with me? And that's what you multiply by. So what we're going to do is we're going to raise this to the 4th power on both sides. Now, what is half of 4? 2. So what I have going on here is x minus 1 squared is equal to, what's a 4th of 4? That's going to be a 1. It's a whole lot easier already, doesn't it? What do? You FOIL this. To give you x squared minus x plus 1 is equal to this left right-hand side. Now what do? Combine like terms. Well, this over here is going to give me a -2. And now what do? I am going to subtract 2x and subtract 1. Subtract 2x and subtract 1. So x squared minus 4x, my 1's cancel out, and my right-hand side is equal to 0. Yeah, sure, there's going to be something else. I can pull out an x. So that's going to give me x minus 4 is equal to 0. Now what?
Solve that.
X is equal to 0 and x minus 4 is equal to 0. So x is equal to 4. 4, 0. Now, are we done? What do you have to do? You have to plug and chug because how many variables did we have in that problem? We had 2, which means could you have extraneous solutions? It doesn't mean you have to. It's just a stronger possibility. So you guys still need to plug and chug and check. So you have 6 problems to do for homework. I already did one of them for you. What do I expect you guys to do tonight for homework? It's all 6 of them, and I expect you to check all 6 of them. Any questions over what I just said? Excellent. The rest of the time is yours. You have a good